Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 3, Check Your Understanding, question number 14. The question is, a small disk of mass m on an inclined plane of inclination theta with the horizontal is connected to a nail driven into the plane with the help of a light inextensible cord of L. So this is the disk, this is the thread, here it is nail, and this plane is inclined to theta from the horizontal. The chord length is L and mass of this disk is M. Coefficient of friction between the plane and the disk is mu is equal to tan theta. So this surface is not frictionless. It is having the friction, and that friction coefficient is mu is equal to tan theta. The disk is given such a horizontal velocity at the lowest position that it moves on a complete circular path around the nail without wrapping the cord on the nail. So lowermost position will be here. From here it has been given a velocity, imparted a velocity, due to which it will start rotating in the circle. It will take a circular path. But one important point here is given without wrapping the cord on the nail. So it means the radius throughout will be L, the length of the cord, because L is not shortening. It is not wrapping on the nail. So to find is where is the disk when tensile force in the cord becomes minimum. Okay. And how much minimum velocity should be given to the disk at the lowest position to round a complete circle. So let us solve this question. Disk was at the lowest position here at A. Velocity imparted is V0. It is attached to the thread or cord of length L. That radius of this circle is L. Center is O. So because of velocity, it will start moving on a circular path. You can notice here that till the first quarter of the circle is 0 to pi by 2 angle, 0 to pi by 2 angle, the component of mg sine theta will be along the or in the direction of the centrifugal force. So it means centrifugal force plus component of mg sine theta in the direction of the centrifugal force will be equal to the tensile force. So means tension will be maximum. But after the point surpasses this A prime point, the component of force will turn towards the center. It's opposite to the centrifugal force. And it will keep increasing at A double prime position. Entire force of mg sine theta will be acting towards the center. Even in third quarter, the component of mg sine theta will be towards the tensile. So let us say that at angle alpha, after crossing this A double prime, the tensile force is minimum. So at B point, if we write the equation of motion from NL and Newton's law of motion, so we can write from the frame of reference of the disk P as centrifugal force in this direction minus T minus component of mg sine theta towards the center. So this will be here. And the sum of all these forces will be 0, because there is no motion in the outwards. There is no motion in this direction. Or rather better to say that since we are sitting on the disk, so we cannot observe any acceleration of the disk. So it can be written as 0. So T will be mv square by L minus mg sine theta into cos alpha. This we can say it as equation 1. Now we'll write the conservation of energy. The total energy at A initially will be total energy at B plus loss of energy due to friction. So we can write here initial energy is half mv naught square. We are taking the potential energy with reference to point A. Okay, so here we have shown that it is having a velocity v. So we can write half mv square as kinetic energy, and potential energy will be mg into L plus L cos alpha into sine theta, because this circle, for the convenience, we have shown in on this plane. Actually it is inclined, so you can see the side view. So this part is your L plus S L cos alpha, that is here in this triangle, and this angle is theta because this plane is having the inclination from the horizontal theta degree. So so this height will be L plus L cos alpha into sine theta. So the potential energy we can write mg into L plus L cos alpha into sine theta, and the work done and the loss of energy will be the work done by the friction force. So that we can write as 0 to pi plus alpha Fr into L d alpha. This is a simple equation. Now putting the value, all this value, we can reach to this mv square is equal to this much mv naught square minus 2mg L plus L cos alpha into sine theta. Now we will divide mv square by L. The whole purpose of dividing is that we want to bring it in the form of the equation 1. Okay, so your calculation will become easy. Okay, so if we subtract minus mg sine theta cos alpha from mv square by L, so we will be getting this equation. But from equation 1, we know that this mv square by L minus mg sine theta cos alpha is your tension force, D. So your equation will become this. For tension to be minimum, we can differentiate this equation with respect to alpha and equate it to 0. So that we have done here. So this is constant, so differentiation will be 0. Here cos alpha will be minus sine alpha, minus is already here. So this will become 2mg sine alpha sine theta. And this will be minus 2mg sine theta alpha. Alpha is, if we dt by d alpha will be, this will be 1. So we can say this is here. Cos alpha will be your minus sine alpha, so this will become plus. So equate it to 0 and see 3 sine alpha is equal to 2mg. So alpha will be sine inverse 2 by 3. So this is your first answer. Now the question B part is asking with what minimum velocity it should be given so that it complete one around. So we can say that it is given a minimum velocity so that it just complete one round and comes at halt coming back to A. So again we will apply the energy conservation. Initial energy at point A will be again the final energy at point A, that is kinetic energy at point A after one round, plus potential energy plus loss of energy due to friction. So initial was this half mv naught square, initial potential energy at A, So half m into v is 0. Final velocity is 0. For this condition to meet, it is to be minimum. Plus potential energy at A after one round. So we are coming back to the same reference point from where the potential energy is getting measured. So this and this will be same. So this will cancel out. And work done by the friction force will be from 0 degree to complete rotation, that is 2 pi. This equation we can write. Now we will put the value and integrate. Put the value, so we will be getting v naught is equal to v minimum is 4 pi gn sine theta whole thing in the bracket square root. So this will be your answer for the second part. Hopefully you understood the concept. Please go through the write-up. In case any trouble with understanding, please do mention in the comment box and subscribe the channel. Thank you.